Welcome back to yet another session on X-rays. In this part, we want to look at X-rays as part of the electromagnetic spectrum, that is the waves of the electromagnetic spectrum. Remember, so far we've looked at the 7 of them generally, and we know X-rays, they are in position 6. That is, they lie between ultraviolet and the gamma rays. They have a wavelength of 10 to power negative 10 meters. But remember, all these rays of the EM spectrum, they exist within a range of wavelength and definitely as well within a range of frequencies. X-rays range from 10 to power negative 8 meters on the side where it borders the ultraviolet. And remember also they do overlap. The X-rays overlap. The wavelength of X-rays will go up to a point where also the UV rays also exist within that wavelength. And on the other side, X-rays get to overlap with the gamma rays. Therefore, their waves exist between 10 to power negative 8 meters up to 10 to power negative 11 meters. Within that range, we can find the X-rays. Please note on the other side, the X-rays do border the gamma rays, and also their wavelengths do overlap each other. And actually, therefore, it means that we can get X-rays with the same wavelengths with gamma rays. But how do we get the difference between the two? If this is gamma or this is X-rays and they have the same wavelength, how do we tell which is which? We are only able to differentiate now between X-rays and the gamma rays by the way in which they are produced. For the X-rays, you find that they originate or they are produced due to energy changes in electrons. And we found that this is where the cathodes are suddenly stopped and we get to produce X-rays. But the gamma rays, they are produced due to energy changes in the nucleus. In the nuclei of an atom, and this is the nuclei of a radioactive atom. So that's a difference between the two. Where they overlap, we can get to know the difference, which is X-ray, which is the gamma ray, only by the way they are produced. So we've seen that X-rays do exist within a range of wavelengths, and definitely as well it will be within a range of frequencies. This time we want to look at two types of X-rays that we call the hard X-rays and also the soft X-rays. In this case, we've seen that if we were to take now the X-rays, the wavelength will exist within a certain range where it will vary from 10 to power negative 8 meters all the way to 10 to power negative 11 meters. So this is a short wavelength and this is a long wavelength. And remember, they have a constant speed of light, c, which is 3 times 10 to power 8. And because the speed will not change, so as the wavelength changes, the frequency will change. Remember, from waves 1, we know that the velocity of waves is given by frequency times wavelength. And because this velocity is not changing, then it means as the wavelength reduces, then the frequency increases. Therefore, for this velocity is the speed of light. So c will be f times the wavelength. Therefore, when we have a very short wavelength, then we'll be having a very high frequency. The frequency will be very high. So the short wavelength corresponds to very high frequency. The long wavelength corresponds to long wavelength. As you can see, the wavelength there is long enough, but in this case, the wavelength is very short. Looking at the energy of X-rays, it's given by the Planck's constant times the frequency. Because this is a constant, then when we vary the frequency, the energy will also vary. And from this we can see they are directly proportional. Therefore, as frequency increases, the energy also increases. For that reason, these waves here with a very high frequency will also be having a very high energy. And these are the X-rays that we call the hard X-rays. These X-rays here have a very long wavelength and therefore a very low frequency. And because they have a low frequency, E equals to HF, the frequency here is very low, it is at minimum, then the energy will also be low. And these are the X-rays that we call the soft X-rays. Therefore, in an X-ray tube, if we want to produce the hard X-rays, what do? Remember, the X-rays get their energy from the kinetic energy of the cathode rays. Therefore, the faster the cathode rays move, the more the energy they are going to give to the X-rays that they are going to produce. So for us to get X-rays of very high energy, then we increase the accelerating potential. We increase the potential at the anode. So they are attracted at a very high speed. Then they will hit the target with a very high kinetic energy. And therefore the X-rays you are going to produce will be X-rays of very high energy. On the same note, if we want now to produce the soft X-rays, we simply want to produce X-rays with low energy. So what do? We reduce the accelerating potential. By so doing, we'll be reducing the speed of the cathodes, therefore reducing the kinetic energy of the cathodes, meaning after hitting the target, the energy they will transfer to the X-rays will also be less. Therefore, to vary the energy carried by the X-rays, we do so by varying the speed of the cathodes. And to vary the speed of the cathodes, then we do so by varying the potential difference connected to the anode, which we call the accelerating potential. Higher accelerating potential, higher kinetic energy, X-rays with a very high energy. That is hard X-rays. Low accelerating potential, low velocity, low kinetic energy. After hitting the target, then you are going to get X-rays of low energy. Therefore, in that case, you'll note that hard X-rays, we have the hard X-rays, and we have the soft X-rays. Hard X-rays, they have a very short wavelength. Soft, they have a long wavelength. Then it means if they have a short wavelength, they have a very high frequency. And meaning that on the other hand, the soft X-rays will have, they have a long wavelength, therefore they have a low frequency. Due to the high frequency, then they have high energy. The hard X-rays have high energy. The soft X-rays, they have low energy. And due to the high energy, then it means hard X-rays, they have a higher penetrating ability. They have a high penetrating energy. They will penetrate materials more than the soft X-rays. Therefore, these are highly penetrative. These have low penetration energy. To produce the hard X-rays, we increase the accelerating potential of the anode. To produce the soft X-rays, we reduce the accelerating potential of the anode. In the next part, we want to look at the intensity of X-rays. So let's now look at the intensity of X-rays. And when we talk of intensity, we are talking of quantity. The quantity of X-rays. And this quantity is simply amount. So how do we vary the quantity of X-rays? The quantity of X-rays is varied using the heating current. When we have or when we need X-rays of high intensity, that is, we need X-rays of high intensity, then we increase the heating current. When the heating current is increased, it means that it's going to liberate more heat. And when we heat the cathode more, when we increase the heating current, that is the heat, then we are going to produce more electrons. Then as the number of electrons that are moving towards the target increase, then the amount of X-rays you are going to produce is also going to increase. When we want to reduce the intensity of the X-rays, then we simply reduce the heating current. Therefore, we produce less electrons, and therefore we are going to have X-rays of low quantity, of low intensity. So please note, to vary the intensity, then we simply vary the heating current. And what effect does this have? When we vary the heating current, then we vary the number of electrons that are produced by the cathodes. So please note the difference between the intensity and the energy. The increasing the intensity will not have any effect on the energy of the X-rays. It's simply the quantity that will increase, but there will be no change in the energy. So the energy is varied using the accelerating potential, but the intensity is varied using the heating current. So we can vary the intensity of X-rays by either having more electrons being produced or having less electrons being produced. And that will happen when we vary the heating current. In our next session, we will be looking at the calculation of X-ray energy.